Okay, so disarm, ignore the monster that's following me. This tentacle on the floor, this type of plant or creature or whatever it is, that's made using inverse kinematics. And I'll explain how it works. Another tutorial. I'm not gonna explain you line by line how it does. I'll show you all the code that I wrote, and I'll show you two ways I did it so that you can have an idea on how you can do the same thing in GameMaker. And if you want to learn how to do this, I highly recommend the channel Coding Math and look up Inverse Kinematics Part 3. That's the video I learned this from. So otherwise, I'm gonna explain you myself as well. I'll show you my code so that you can know how it's possible to implement it in GameMaker. So I'll show you how it works basically. Okay, so so you have different parts of an arm. Maybe let's say this is the start. So that just to remember where it's supposed to begin because you want it to stay on the floor. Then you have the arm, that's right here. It's maybe like this, then like this, and then like this. And then you want to reach the target. It's gonna be here. What to point this ball here. So how does it work? It's actually simpler than it sounds. The first thing that happens is you change the angle of this. So right now it's pointing towards the top. You just erase. You change the angle. Now point towards where you want to go. So obviously you can't reach it. So you just change the angle. Right? It was like this. You rotate it this way. Then what do? Do you check for a bunch of stuff? Nope. You grab it, then you move it right there. Then what do? You do the same thing with the next one. So you change the angle of this one, point towards over there, towards the beginning here, basically the x and y coordinates of the next segment of the arm, basically the next part. So you point towards there, and then same thing. You just grab it and you move it right there. And then you do the same thing with the last one. Change angle, and you point towards here, and then you move it. That's basically what you do through code. And then if you wanted to keep it tight there, so if you just with this, that's already inverse kinematics, and you could leave it like that, and it will work. It will follow the player a bit like a snake, or the mouse, or whatever you want it to follow. But if you want it to stay tight, then you can't leave it like that. It's exactly the same thing, but you can't leave it there. So what do? Well, you calculate the distance between this. Let me write color that. So you check the distance on the x-axis. So that's maybe I'll say it's 20 pixels, maybe something else. And then you check the distance on the other axis. It might be 20 pixels as well. So what do? You grab each part. So you take this, move it 20 pixels down, 20 pixels left. So now it's back to where it was. Then you do the same thing here. 20 pixels down, 20 pixels left. It's back here again. Then do the same thing there. 20 pixels down, 20 pixels left. Now, as you see, it's not pointing in the right direction. It's a bit off to the right. But in the beginning, it was much worse. In the beginning, it was basically like this, and like this. And now it's almost pointing in the right direction. So it's progress. And since this happens 30 or 60 times per second, it's gonna self-correct. On the next frame, the same thing's gonna happen. So this is gonna be, oops. So this is gonna change direction again. Now it's gonna point more towards the green thing. And now it's already basically already correct. And then again, same process. Gets moved there. Then this one, same thing happens again. You point towards the end of the other thing, and then you move it. So it's really in this step. You change the angle first, and then you move it. Then you drag it. Then same thing again here. Point towards the other end. You drag it. And then what you do, you check the distance again, like before. Oops. And you move it back. And now again, it's a little bit off, but it's almost pointing directly in the right direction. So this is inverse kinematics. This is how it works. If you understand this, you could go right ahead and create your own system in GameMaker if you code well enough and you know enough to do it. You understand different ways of doing it. So if you understand this, you can already come up with your solution yourself and make it happen. But I'm going to show you my code, and I'm going to show you two versions of my code. I'm going to start with, which one should I start with? I'm hesitant. I'll show you this one here. So the one that you saw in game, the plant on the ground trying to follow the player. So I'll show you again just so that you remember a bit. Well, I don't know if that was necessary, but I'll show you. I'll show it anyway. So I'll tell you the main difference. There doesn't seem to be any difference really with my other version, which you didn't see. But I'll show you. I guess I'll show you right away. But I'll show you the code first, and then I'll show you the other versions afterwards, and you'll see why it's different and why I think this one is better. The main difference is that they're instances. So that means if you don't want to worry about memory leaks, that's a solution because instances get taken off by GameMaker automatically. And that's one of the reasons why I decided to do that. I don't want to worry about memory leaks and list and when to destroy them. Usually the cleanup event works fine, but I've had problems with it. So if you don't know, the cleanup event runs automatically whenever you do the destroy event, but not only when it's destroyed. Even if the destroy event doesn't run, the cleanup event will run anyway. So if you change room, the destroy event might not be ran, but the cleanup event will be. That's in theory. I've had problems with the cleanup event in the past, so if I can avoid it, I do. So here's the code. Well, first I'll show you the segment. Draw joints isn't very important, so you could ignore it. Image speed isn't important either. What's really important are these two variables. That's important. So the reason is each part of each segment, each arm, each tentacle, each part needs to know what it's tied to basically. So for example, if it was a human arm, your hand needs to know that it's tied to the end of your forearm, and your forearm needs to know that it's tied to your elbow, and so that's basically why it's like that. Everything has to know how it's connected. So that's it. That's all the arm segment has. And outside of that, there's a draw event. But the draw joints is just drawing a circle to make it look a bit better. So, well, here I'll show you what it's doing. So, oh, I forgot to show you the sprite I'm using for the segment. So here, that's basically all it does. The draw joints, it is this, and then there's the side of the joint. So here it looks even more like a robot arm because it looks like it could be some type of machine. Let me show you the sprite. Where is it? Sprite segment. Okay. So it's 2 by 2 and it's middle left. The reason I did middle left is because it means the x and y coordinates are going to be the one end of the stick, and then if you add how long it is, you get the x and y of the other end. So you only have to do one calculation. I think it's easier this way. That's why I don't put it in the center. The reason it's 2 by 2 is because I don't trust GameMaker to handle the width and height and collisions properly if I use a 1 by 1 pixel. So I use 2 by 2 because this way I'm certain that there won't be any bugs. So 2 by 2 sprite with middle left as the center of origin. That's what's necessary for the segment. So arm manager, create event. So arm init is basically, I'll show you what it is. Takes the total length of the arm. So let's say you want it to be 100 pixels long in total, regardless of how many parts it's made of. That's the variable for it. And segment count, how many segments are there? Do you want 3 so that it looks a bit more robotic? Do you want 50 so that it looks really smooth like a tentacle, an organic thing, or a string like a rope? Um, per segment width, last segment width, that's basically to make it easier on myself to change how wide each segment is. So let's say you want to start at 20 pixels wide and end at 10 pixels wide. There's a calculation that's going to make sure that it smoothly goes from 20 to 10 pixels wide. So that's for convenience basically. That's all it is. Owner, that's to be able to tie the arm to something. So the arm was tied to the player. That's because I added an owner to it. But it could be the floor. There could be no owner and be tied to the floor and it will work. Segment length, that's the calculation to know the length of each segment. So the total length divided by how many segments there are. Position, that's just a detail. So it's to decide between trying to aim for trying to be at the middle of whatever we're following, or at the top or the bottom. So that's not an important thing. So these are what's important. The target is the object it's trying to follow. So in this case, it's not trying to follow anything except the mouse. So that's the default. The default is the mouse. If there's no target, it's going to try to follow. But otherwise, it could be the player. So if I do this just for fun, the tentacle will follow the player. So basically, it's going to do some type of circle, I suppose. Probably going to look funny. Oh no, because I didn't tie it to the player. So I need to change the owner. But that's not what I need to change. It's owner that I need to change. Normally you wouldn't change it here, just to show you what it does. Because you can change it somewhere else. Yeah, so like I said, it's following itself. It looks like I'm carrying some type of weird arm. Because anyways, we now see what I mean. So back to the main code. The create event doesn't have much because um, excuse me. This is basically the manager. This is the thing that manages the arm. Excuse me, I'm drinking some water. and I don't necessarily want it to act. I don't want each arm to be exactly the same. There's a default one, but maybe I want something different for other things, like a player leg, which I did. That kind of fun. I'll show it to you later. But so yeah, so I set an alarm, and then 2 steps later, then that's the real create event. So I create a list, then I get the width for. So basically, this starts with the initial width, the width of the first segment, right? And then the width changed. This is a calculation. If you want to do the same thing later, so the last segment width minus the first segment width divided by segment count. Excuse me. But okay, so here's the important part. So just create each segment, adds it to the list. The list is temporary. I destroy it, I delete it afterwards. It adds each segment to the list, sets the image scale to segment length divided by 2 because the sprite is 2 by 2 and is supposed to be the size in pixel. So I divided by 2, same for the width. Then I update the width by the change. So to update it, next time it's going to be a bit smaller. So this basically creates each segment and sets their length. I could have used a length variable, but I used image x scale because I want the hitbox to be different, the bounded box. So that's why I'm using this. Otherwise, it would be length and width. Then I do another for loop. I attach each segment to its previous one and to the next one. So at 0, that's the main parent, so you won't have any parent. That's why there's an exception here. If I equals 0, current segment dot parent equals no one. So, and same for the last segment. The child is going to be no one because there's not another segment left. But otherwise, it just basically ties each segment to the previous one as a parent or to the next one as a child. This is what this code here does. That's all it does. Mm, I'm confused by why I put this here. I am very confused and I'm wondering why there's no bug here. I'm not even sure I need this here. Let me check something. Let's see if it breaks. I might do a real tutorial afterwards where I really explain how to do it right. Yeah, I don't even know why it should have caused an error, but it didn't. And I'm very confused because this shouldn't work. It should cause a bug when you get to I don't know. I don't know why it didn't crash. This shouldn't have worked. But I guess it was working. So this ties everything together. Yeah, I'm really confused. But anyway, so this ties each segment to the next one and to the previous one. Then first segment and last segment, that's to remember, uh, basically to keep track of the arm, right? Because this manages it, but otherwise it's not tied to it. So that's why I store the first segment and the last segment. Because that's all we need to know. And this isn't important. That was just code that I made so that each tentacle goes to the ground. Each step when it's at the ground. So you can ignore this. This isn't important. So that's the code for the creation of it, basically. So for the step event, well, first in the beginning, there's the create event hasn't ran, so this won't be initialized. So that's why there's this check here. Here there's a default target. I mentioned it was the mouse. So, but otherwise, if there's a real target that exists, He's gonna try to find it, and yeah, that's gonna be the target that we're trying to touch, basically, that the place we're trying to reach. Then here there's a loop, and you basically check the distance between I'm a bit confused by my own code. I don't know why that works either. This should have been sprite width and sprite width. So let's again try to see if this works. Let's see if it's gonna break. This shouldn't work. I'm not sure why this is working. It shouldn't work. Let's see. Let's see what happens. So I am confused. If I change something so badly, why is it still working? Is this even is this even useful? Oops. See what happens if I remove this. Well, so yes, it's useful. So then I don't know why my code works. So that's good to know that you don't know why your code works. These two work exactly the same way. And that's the difference between, well, I'll just leave it like it was. I don't know what's happening here. I am very confused. I am very, very confused. Well, this great. I don't know why my code works. That's great. It does, but I don't know why. Wait, sorry about this. I thought I would remember how it works. I made this like 2 days ago. That's the mouse and subtract. Maybe this part doesn't matter. Oh yeah, it does matter. It's gonna be a long video. I didn't plan. Well, so clearly it's important because it doesn't work if I remove it, right? So I guess it's important. I am so confused. I am so confused. Well, the good thing is it works, I suppose. I I am very confused. That's what I was expecting. I was expecting something like that. But instead of having something like that, I have something called base code. Well, I'll show you the other one I made then. But usually that's basically what I said earlier. You're supposed to point in the right direction, which is what this seems to be doing, and then move towards this direction. And yeah, I'm not sure why it's not working. What happens if I put 200? Oops. Oh, okay, okay, okay. I know. Okay, okay. I got it. I got it. Finally. So yes, the reason why it worked when I did sprite width is because they're the same, right? So this will make a lot more sense if I would have put sprite width. Okay, sorry about that. I That's more clear. So maybe that's why I should have put a name like length as a variable, because then I would have known exactly what this was supposed to mean. So here's a lesson. Use variables that help you remember the meaning and what they're used for and why it works. So yeah, that's a lesson. That's a tough lesson learned. Okay, so that's basically the thing I talked about earlier, where you check the distance and then you move accordingly. So you point towards where you want to go, then you move the segment towards that place, and then you switch to the parent segment, and then before changing, you set the new target x and y to the current coordinates. So the thing I talked about here, where you point towards there, or you point in this direction, and then you move in this direction, and then you do the same thing with the next segment. This is what's happening here. And I use image scale times 2 instead of sprite width. I should have used sprite width. Sprite width is the size of the width of the sprite, and if image scale is multiplied by 2, then this is going to be twice the size of the width of the sprite in your resource tree. So sprite width, and that's what works basically. I got so confused for a while, but I finally understood what I was doing. So the video is probably getting very long. I'll just quickly go over a different method of doing it. This one I use a list. I'll show you what it looks like. So they're not tied. So this would happen if they aren't fixed. Me fix sticks. So it works exactly the same way. It's just the code behind it that's different. This video is getting long. Sorry about that. I didn't expect it to take so much time. Maybe a blog would be better than this. Maybe you should write an article instead. Maybe it would be quicker. So, okay. The snake is basically a tentacle. It's the arm. Because I'm not using instances, I'm using lists instead. I like lists because, well, I like them. So I use an enumerator to remember which position in the list, which is like an array. determines which variable, basically using lists as if they were objects. So armx, the x position, the y position, the length, the angle, the width. And because of this, I probably wouldn't have been confused by showing this one first because I'm using proper named variables. So the create event, I create a list of segments, just like in the other case, but I keep it, I don't destroy it, and I don't tie each segment to each other. I don't need to do it because I keep it all in the list. So, but because I'm using lists and I'm not using instances, I made scripts so that I can get the x and y at the beginning of the segment and the x and y at the end of the segment. And so this is why this is here. And the way you get the end segment is using the lengthier functions and the angle and the starting position, which is simply x and y. So um, basically, now it's stored in an array. I could have made it clearer by writing it here, but basically, and x equals x plus lengthier x arm length arm angle. This is the same thing here, except that here it's not as easily read because I was lazy and that's how I wrote it. I thought it would be easy to read. It isn't. I would rewrite it this way. So, so yeah. So this is what this is. And then you do the same thing on the y-axis for um, oops, for snake arm get y. So here I think I was just positioning each. Oh no, I'm creating the snake basically, and I'm adding it to the end of the previous part. It's not necessary, just I guess to make it easier to get started. So in user event one is basically the step event, the way I made it in this thing. So just although it says user event one, it's basically step event. So same principle, have a target X, target Y. Is the snake AI. Basically that's just an object, like an invisible ball that tries to reach the player, and it has a speed and it has acceleration, so it's not instantaneous. So instead of teleporting directly to where it wants to go, follows a ball that slowly gets there. So same principle, I start with the head, and then instead of having the child and parent variables, I just use the index in the list. So the arm is okay. Well, first I move the first segment basically outside of the loop. Then I start the loop for loop at one because I already did with the first one, right? So I don't need to do it again. And then I get I basically update the position. That's what I do here. I'm a bit curious as to why I use the x and y instead of getting the end x and the y. Oh, because that's exactly what I want. I want the x and x. So then I drag. It's basically the same thing. I have a hard time explaining myself because there's actually a lot going on at the same time. But it's the same principle. The best way to explain it was with the image, like I showed you earlier. So just keep in mind that this is what it's doing. It's changing the angle of each segment towards what it wants to go, and then dragging it there, and then jumping onto the parent, or in this case, just the next index, and then doing the same thing again. So 0 is the head, and the last segment is the tail, basically the highest number. So it's basically the same thing, but I'm using scripts instead. And what's great about the other method is that I don't need to transfer scripts if I want to do it. Here, I would have to import all this just for my snake arm. But in the other the other game I'm making, I don't need to have all this. It's just in two objects, the arm manager and the arm segment. That's all I need. So I think the other method is better. Plus, well, anyway, I think the other method is better, and I don't need to. There's no risk. I don't need to destroy all the lists when I'm destroying the arm. It's a bit more complex if you stick to the list. So I prefer the other method. And yeah, so that's basically the code, right? I don't think I have anything else I need to show. Here's the same thing I talked about. When you're at the end, you need to move back the whole thing. So the x distance on the x-axis equals the x of the first segment, basically the last segment. Sorry, it depends on the order you do it. And yeah, and you just move it back. You loop through all the segments, and all of them subtract the distance. So you basically slide the whole thing back to the base, the main position. So yeah, I guess that would have been a very long video. I didn't expect it to take that long, and a part of it is my fault. Sorry about that. But yeah, so that's how you can implement it in GameMaker. I might make a real tutorial if you're interested. If you're interested in that, I'll do it. But otherwise, for now, I just recommend that you take the video from coding mat. Inverse Kinematics Part 3. It's where I learned it from. So yeah, let me know what you think. My microphone isn't very good. I know the video wasn't perfect, and there won't be any editing, so I know there's a bunch of things I could improve, but I just wanted to show off my code. So if it helps, I'm very happy about that. Thank you for watching.